Any object immersed in water experiences an upward vertical force equal to the weight of the water it displaces. This is known as Archimedes' principle of buoyancy. Wood, for example, is less dense than water, so its weight is less than the weight of the displaced water. That's why it floats. Its upward buoyant force is stronger than its downward weight. If you take a piece of food to the bottom of the water and let go, it will float back up to the surface. What applies to wood in water also applies to a balloon in air. Balloons rise because they are lighter than air. But how can a balloon be lighter than air? Air is a mixture of gases that has weight. 1 cubic meter of air weighs about 1 kilogram, which contributes to atmospheric pressure. The density of air allows airplanes to fly by providing lift. A balloon consists of a fabric envelope and a basket, both of which have weight. But the envelope is filled with a gas that is lighter than air, meaning it is less dense. In the end, the combination of the fabric, the basket, and the light gas results in an object that is less dense than the surrounding air. And that's why the balloon rises. But what is this lighter-than-air gas? We use helium, as in amusement park balloons. Lighter than air, helium makes the balloons fly, which is why you have to hang on to the string. Well, the Generali balloon works the same way, only it's about 1,000,000 times bigger. Filled with 6,000 cubic meters of helium, it can lift nearly 5 tons. But unlike fairground balloons, the Generali balloon is tethered to the ground with a metal cable. This makes it a captive balloon. The cable is connected to an electric winch that controls the balloon's height. The balloon naturally pulls upward, so to ascend, the cable is let out. To descend, it's pulled back in. The winch uses no more electricity than a regular elevator, making this balloon the least polluting aircraft in the world. To manage changes in outside temperature, the balloon's envelope is divided into 2 compartments. The upper part is filled with helium, and the lower part is filled with air. Since helium expands in heat and contracts in cold, air is added or removed to balance the pressure and maintain the balloon's round shape. The balloon performance is highly dependent on weather conditions, especially wind. When the wind blows, it pushes the balloon sideways, causing it to tilt from its vertical position. The stronger the wind, the more the balloon must compensate by pulling upwards to stay upright. To maintain this balance, the balloon needs to remain light, so the number of passengers must be limited. This is why, when the wind picks up, fewer people are allowed on board. If the wind becomes too strong, the balloon must land and be secured, much like a ship returning to port. Above a wind speed of 35 km per hour, flying is no longer possible. Standing 34 meters tall and with a diameter of 22.5 meters, this is the world's largest balloon. It can carry up to 30 passengers per flight at an altitude of 150 meters, which is equivalent to the second floor of the Eiffel Tower. The balloon is visible from up to 20 kilometers away and is seen daily by around 400,000 people. For scientific purposes, it can climb as high as 300 meters. A true flying laboratory, the Generali balloon constantly measures air quality and greenhouse gas concentrations.